Good afternoon and welcome to the session number 2 from the playlist of Dual Nature of Radiation and Matter. The topic is the photoelectric effect and this session is in the continuation of the session number 1. So based on this topic, I have written here 2 important points which will help us to understand this topic in brief. The first point is the definition of the photoelectric effect, and the definition of the photoelectric effect is that it is the phenomena of emission of electrons from the surface of the metals when light radiation of suitable frequency is incident upon it. So these ejected ejected electrons, they are also called photoelectrons. Now the minimum energy which is required to eject the electron from the surface of the metal is called the work function of that surface. The frequency or the wavelength corresponding to that work function is called the threshold frequency or the threshold wavelength. So the minimum energy which is required to eject the electron from the surface of the metal is called the work function of that surface, and this happens when light radiation of suitable frequency is incident upon it. Now the work function is denoted by phi naught, and this is equal to h f naught, and this can be written as hc upon lambda naught, where c is the velocity of the light in vacuum, lambda naught is the threshold wavelength, and f naught is the threshold frequency, h is the Planck's constant. So by using the Einstein photoelectric equation, that is hf is equal to phi naught plus k maximum, that is this hf is the energy of the incident photon, and this is equal to the sum of the work function and the maximum kinetic energy of the photoelectrons. Now here the energy of the incident photon is utilized in ejecting the electrons from the surface of the metal and imparting the kinetic energy to it. So this equation, that is the Einstein photoelectric equation, can further be written as hf is equal to hf naught. Now here I have substituted the value of phi naught as hf naught in this Einstein photoelectric equation. So this hf is equal to hf naught plus half m v max square. Here v half m v max square is the current, this is the maximum kinetic energy of the photoelectrons or the ejected electrons, and v max will be the maximum velocity of the photoelectrons. And this equation can further be written as hf, which is equal to hc upon lambda naught plus half m v max square, by substituting the value of work function as hc upon lambda naught. Here c is the velocity of the light in vacuum, lambda naught is the threshold wavelength, m is the mass of the this photoelectron, v max is the maximum velocity of the photoelectron, h is the Planck's constant, and here f is the frequency of the incident photon. So thank you very much for joining this session. In the next session, I will be discussing about the energy and the momentum of the photon. So till then, have a nice day. Bye.